Hello and welcome to Urvak Shit Dump. Firstly, I would like to say that I'm in one of the nicer classes on campus right now. This is like one of the interactive things that they tried. I don't know, they should have all classes like this. Anyhow, uh, today we are gonna talk about futurism and sort of the technologies that I'm excited would come in the future. And we will talk about like near future and also a very far future, maybe even like centuries ahead. So let's see. So, what are the kind of recent technologies I'm very interested in? One of the things I guess we should realize is that the chips revolution might not just stay isolated with uh, might not just stay isolated with um, uh, electronics. So okay, everything is going to be electronic now, but what I mean is the single sort of silicon semiconductor things that we are using are not the only things we can manufacture at a sort of micro scale. So, what are the other micro scale manufacturing products can we make? Okay, and here are some of the technologies that I'm aware of, which is firstly is MEMS. Now MEMS is already very popular. MEMS stands for micro electromechanical systems, and it's already used all the time with gyroscopes, accelerometers, antennas in phones, laptops, etc. We also have MEMS based microphones, which are used often on like earbuds and things like that. And sort of one of the better things one of the other interesting applications of MEMS includes projectors. So we can make micro scale mirrors, and each pixel is a mirror in the projector. So what are micro electromechanical systems is again small systems which can move. So these are mechanical systems, and they can move because of electricity. They can have electrically powered movement. And sort of a few things that I'm interested in future is MEMS based speakers, because we can have much better audio quality sometimes, and in much smaller form factor. So and you can see even say today, for example, traditional microphones are still better quality wise. MEMS based microphones are only used where we have to pack it in a small place or we have power restrictions, etc. But we can see a future where maybe MEMS based microphones are just better than traditional microphones. And the same with speakers, we can have MEMS based speakers, and there are companies who are already working on this, who already have products out which are MEMS based speakers. MEMS based speakers are used in like medical devices, but we can see it in and I would love to see MEMS based speakers in consumer devices soon. Another sort of interesting MEMS product is screens. So as we saw that, like I love the idea of e-ink displays, because firstly I love how you can just power it off and it would just keep the image on screen, and I like the idea of absorptive displays because obviously they consume a lot less power because they are no longer emitting light. And uh, uh, if you take these monitors in uh, and they look like paper, they don't, and sometimes, and I guess that might also help with eye strain. But the problem is that it's very difficult to make ink displays which are good resolution, fast refresh rate, and color, which, but we can do this with micro electromechanical systems where we can we already use this mirror kind of array in projectors. We can have some kind of a system, micro electromechanical system, which can be used in screens, in monitors, and this might reduce power consumption. This might result in just a better quality, and we can also illuminate these screens, and we see that we don't need to illuminate these in bright environments. So this is completely opposite to emittive screens, where brighter the environment, brighter screen you need, while sort of absorptive displays like this would perform the best in bright environments, and our monitors today are too bright for darker environments anyways. I was looking at this thing where on the iPhone they brought this feature where you can make it very dim, and this is like in the accessibility settings for some reason, but that is a feature because in dark environments our screens are often too bright, and so these screens don't necessarily need to be bright at all, and when it is actually illuminated, and now these monitors have knock-on effects, because now obviously you can easily see that since monitors are one of the bigger energy consuming devices on a computer or on a phone, we would need smaller batteries if we use these types of monitors, and obvious advantages, so that thinner devices can be achieved. Another sort of systems on chips which are interesting are okay, another micro electromechanical system is, I believe, like LiDAR. I guess this is also related to silicon photonics, so we'll talk about it in silicon photonics. But and also quantum sensing. Okay, so silicon photonics and other kinds of photonics which can be made on chips can also revolutionize firstly computing. So we might be able to compute faster if we do it with light. That's the idea. Sort of other interesting things can be done, which is if you have silicon photonics chip that can run on multiple frequencies at the same time. So that might just be one physical core of the processor, but that core can be done on several different frequencies. So if we run it on 64 different frequencies, we have 64 virtual processors which are all independent, even though there is just one physical core. So, and these devices are more power efficient, and that also releases a lot of heating issues. And so if we can have photonic chips, again, power means smaller batteries, and better performance. I don't know what we would do with better performance now, at least on consumer devices, except gaming. But yeah, silicon photonics could be used there. Silicon photonics can also be used for like LiDAR, and I'm really interested in seeing like quantum sensing sort of measures applied in security checks. So today we just either use a metal detector or we use uh, I think there are other detectors which are better, but we can use quantum sensing. For example, there are like I'm just speculating here, but let's say we use uh, I forgot the name of this thing, but we can detect we can essentially detect the phase shift of photons as they pass through a material. And say, for example, we use a wavelength of photons uh, uh, which is not which just passes through all normal materials. We can have machines which will just scan you, okay, by amount of phase shift that each different materials cause in the photons. And this could obviously be used for medical purposes, but can also be used for like security screening, for example, at airports. This, for example, linked with AI can be just you could just walk through these detectors, and that might increase our efficiency in those respects. So that is application of this kinds of technologies. Uh, um, Another interesting things is like medical that could be for silicon photonics is detecting molecules and sort of doing laboratory testing, but with much better results. And you could have this system even maybe on your phone, for example, or on a small sort of chip devices, sort of disposable things as well. And you could say, for example, do blood tests. There were sort of certain devices that they were using it to like check fruits for pesticides. Okay, so we can do these kinds of molecular testing with sort of very there could be consumer devices also doing it, and also these have applications on the commercial and more industrial side. Another now sort of thinking about energy. Think about we have only really discovered electricity till now. So what are so everything we do is still just electricity, and but let us think of some sort of what other sort of things could be developed. One of these things that I thought was heat. We don't really have a efficient way of transporting heat. So heat could be thought of as like high entropy energy, and electricity is like low entropy energy. So we know how to transport low entropy energy, but we don't really have a method of transporting high entropy energy. And I believe we can like have these empty copper tubes which would transport very high amount of heat across them. And I'm not sure, but maybe it is related to infrared emissions inside that tube. But let's say we can have a large scale system like this, and this sounds like a good idea, where these pipes transmit a very large amount of infrared light, and we can essentially transport heat with this. So if you have a line which is say 200 degrees, it will just stay 200 degrees. You can like add or subtract heat. So if you want to cool something that's hotter than 200 degrees, this could act as a drain. And if you have something that you want to heat up, this could be a supply. And so the supplies and the drains might cancel out. And if we keep having energy revolutions, if we sort of maybe have fusion, we would have like too much energy. we might like sort of we are energy constrained right now, but that not might not be true in the future. And there are speculations that say we might be uh, um, sort of heat dissipation limited in the future, and so these technologies might be used to cool things because we might have sort of energy abundance in the future, but we might not have cooling abundance. Cooling could be a big task. The good thing about cooling is that firstly you could just like evaporate water, and so uh, that there are not many environmental concerns with cooling something, especially if you just evaporate water eventually. And if we are evaporating water, we can use this to desalinate as well. So there might be co-desalination plant, which again a large amount of cost of desalination plants is related to heating. But if we are having this kind of an economy of heat, and then desalination plants could just be cooling plants, and there could be co-desalination, which can alleviate our water concerns. Another sort of interesting but think about it, we might have sort of consumer level pipes which are colder, so that would be safer. Think about a line which is like 15 degrees Celsius. This would be perfectly safe line. What's the worst thing that could happen? Something would cool down to 15 degrees Celsius. So, so even like we can alleviate safety concerns if we use lower temperatures. And so these might be more expensive because on the other end, if to evaporate water, we would need to like pump heat now, and that would take energy. But yeah, we can also have like consumer grade things. So obviously the easiest, the like simplest applications would be air conditioners and fridges. Also, if we can get heat, we can use it to heat the buildings or heat water. And this might be much cheaper than using, say, electricity for this or etc. And this we can just like transport heat this way. Another sort of looking into like very much future, I was like thinking about batteries. Firstly, I think there might be a way of creating like silicon like based chip batteries. Like, why can we like create some kind of a microstructure in silicon, which just stores a lot of energy? I don't know. Diodes can store energy, so we should be able to create some kind of a microstructure, which just like we have like an immense surface area now, and we store a lot of energy in silicon. I don't know if that could be done, but that is one of my ideas. But sort of thinking about like today we transport electricity through energy through sort of pipelines. Okay, so even like electricity grid is a pipeline. It is like we have to connect the pipes to transport large amounts of energy. We don't have a good way of transporting energy sort of in sort of batteries or something like that. So some good form of store of energy. And if you look at like in sort of a lot of movies about future and sort of space, future civilizations or aliens, many a times we see these sort of, there is this common fantasy of a crystal, which just has a lot of energy. And I was thinking, can we make something like this? And my sort of, before we talk about the crystal energy thing, we would talk about silicon photonics RAM. Okay. So you know how in past many one of the ways in which they would make memory. So today we use random access memory. So random access memory is if you give any address to the memory, uh, the time it would take to retrieve the data from that address is the same, regardless of where the memory is located. While there could be a CD's access memory where you just feed it data and it would give you back the data after some specified time, okay? And the data just goes on a loop, okay? So for example, one of the ways this was implemented was you could have a column of mercury. And this column of mercury you would have some kind of speaker and a microphone, and you would just release sound waves which would encode your information, and it would wait for some time and then reach the microphone because sound has a speed, and then this microphone can be connected to the computer, so the data is read that way. And the same microphone is then connected to the speaker, so then the same information would again go through this CD's access memory. So we often have, so there is CD's access memory we have used in the past, and we can, but Silicon Photonics provides us with an opportunity to do this sort of a modern version of it, where we can transport light through a medium and then detect light on the other end. Now the good thing about light is we can actually just make a loop and let the light travel in the loop. Now this light might need amplification, which is quite easy to do with lasers and electricity, okay? But I'm not saying quite easy to do in that sense, but we might be able to do this. And this would result into RAM. So one of the interesting circumstances, like one of the interesting thoughts about like the exotic materials we have to use for these things, is that we would like this light to be slow so that we can transport, so we can put more information in the same length of this tube where we are storing information, and so to slow down light, the materials with higher refractive indexes have slower speeds of light in them, and so the material with the highest refractive index is diamond. So we might be having RAM which stores information in diamonds by passing light through them, which sort of sounds really amazing. But so, and think about, I was just thinking this might be a very good way of storing information, even if we needed like, the problem with this is this storage system is volatile. Okay, one of the good things is, for example, if we store 4 KBs in this CD's access memory per sort of a cell, it should solve because even modern RAM gives you sort of 4 kilobyte chunks when you ask them. So modern RAM is not random access in terms of bytes, but in terms of 4 kilobyte sections. So so if we have cells which are each 4 kilobytes, this kind of a photonics RAM can act very similar to modern RAMs. But these RAMs might just be too good. Let's say we might live in a future where RAM memory is cheaper than any non-volatile sources of memory. And this is some kind of an economic change that can happen in the future. And is that Today, non-volatile forms of storage, such as hard disks or SSDs or tape memory or DVDs, all of these are cheaper than RAM, which is non-volatile. But sort of being non-volatile is a disadvantage. But so you are getting this disadvantage, and you are paying more for RAM per amount of data stored. But well, obviously the benefit is faster access. But what if we had a volatile form of memory which is cheaper than non-volatile forms of energy, such as with silicon photonics? RAM might be cheaper than non-volatile forms of storage. But if you think about it, especially when it comes to things like cloud storage, we might just be sufficient with RAM. What if if RAM is so cheap, we can just store things in the cloud on RAM, okay? That not only does does for like faster access, but it also but because servers they are not going to power down, so if it's cheaper to store energy like that, servers might use this kind of system. And so cloud storage might become much cheaper than having any form of storage on your own. Well, can you have this kind of a RAM storage on a consumer device? I don't know, maybe if you can have some kind of a unlimited energy stores, such as we were talking about in terms of the crystal, but also there is some sort of fake hype about nuclear batteries and how they can store carbon-14 inside diamonds, and they would use like a beta voltaic battery to for it. But these kinds of batteries, nuclear batteries, can only give like microvolt of power, watts of power, which is very, very low. Okay. So we were talking about like crystals, energy crystals, right? Before we started on this silicon photonics RAM thing. But this is some kind of a very imaginative design of this crystal, and so some kind of a crystal I can store energy. Why does this idea good? Okay, why is this idea worth exploring? Well, this idea is worth exploring because as we manipulate structures at a smaller and smaller scale, we are achieving better and better technology. All modern technology is based on microstructures. Not all modern technology, but a lot of modern technology is based on microstructures, creating microstructures. So what is the microest of microstructure? Well, is to create essentially a crystal, is to put individual atoms and decide bonding between individual atoms. And so sort of this might be very difficult if you want to if you have a map of a device based on individual atoms and you want to create that device. But crystals have repeating the structures, and so you can have like some kind of a very complex crystal which would never grow naturally, but we can manufacture these crystals, and these might have sort of exotic properties. What kind of exotic properties you might have? I'm sort of going to semiconductor sort of an idea, but these crystals might be able to, say for example, act as batteries, right? You could pass electricity through them, and that would change sort of some kind of a bonding inside the crystal, but making it less stable. And to go to a more stable state, again, the electricity has to pass in the reverse direction. And so we can store energy this way. But we cannot reach sort of extreme densities of power this way. because eventually this is also a chemical mean of storing energy. If we need to store sort of exorbitant sort of energy in crystals, we have to crystals or in any material, uh, we have to look at the nuclear options. Uh, and again, thinking some kind of a imaginary thing. What if we can store antimatter in crystals? So we can have these spaces in this crystal where sort of maybe a positron can get trapped and it would not annihilate with any electrons or anything like that in this crystal. Or maybe if they annihilate with another electron and give say two gamma rays as they do, this crystal might just absorb these gamma rays and allow electrons to pass through this kind of band gap, just charging the battery again. Okay, something like that. I don't know. So slowly these electrons would, these positrons would fuse with the electrons and would release gamma rays, which would be absorbed by the crystal, causing electrons to move in its band gap and essentially move from one side to another of the crystal, and then we just connect, and then we have, and that's a very good battery. Okay. So for example, I was just also thinking how it is so beneficial to put solar panels in space. Sort of, can we put solar panels in space and like transport the energy to Earth, which is a sort of interesting idea. So mostly people think about things like a microwave or laser links to ground, etc. But again, these are all piped solutions. But if we want to transport energy like this, what if we have these crystals in which you can transport energy? And if space energy manufacturing is extremely cheap, we can also waste a lot of energy storing or transporting that energy, and it might not matter. It still might be cheaper. So, for example, if these crystals could be, for example, to get positrons into the crystal, we might need to irradiate them with gamma rays. Okay, but because I know that gamma rays can split into positron, electron pairs, etc. But to do so, this might be a very inefficient process. Say only 40% of the energy is stored in the crystal. Well, if energy is way cheaper in space, we just irradiate these crystals in space and bring them to Earth. And this might be a very sort of renewable and very environmentally conscious way of energy. And we just transport these, crystal things, empower, buildings with one of these or something like that. I don't know, I'm just like saying. So these are my sort of imaginations about future technology. Thank you.